Hello friends, in today's question, two blocks A and B of equal masses are released from an inclined plane of inclination 45 at t is equal to 0. Both blocks are initially at rest. The coefficient of kinetic friction between the block A and the inclined plane is 0.2 while it is 0.3 for block B. Initially, block A is root 2 meter behind the block A when and where their front faces will come in a line. So we have two blocks A and B. So B is in front by the distance of root 2 meter, and we have to find out when and where. It means the time and the distance at which both the blocks will be coming in line. So let us start with block A and draw a free body diagram. So we can say for block A, so this is 45 degree, and we have block A, and in the downward direction, let us suppose this is MAG divided into two components. This will be 45, so we get MAG cos of 45, and this will be MAG sine of 45, and the normal NA, and we assume that it is moving down the inclined plane with the acceleration of AA. So the friction will be acting upward. Let us suppose that is FRA. So we can write that our FRA will be equal to mu A, that is, it is kinetic friction multiplied by NA, and NA is equal to MAG cos of 45. So we substitute it here, we get mu A MAG cos of 45, and we can write the equation for the motion for block A. You can say MAG sine of 45 minus FRA will be equal to MA multiplied by AA. We substitute the values, or rather FA first of all. So we get MAG sine of 45 minus mu A MAG cos of 45 is equal to MA into its acceleration A. MA cancels out throughout. So from here we can say our acceleration A, G is our 10 sine 45 1 by root 2 minus mu A is given as 0.2, G is 10, and this is 1 by root 2. So we get the acceleration of A will be equal to 4 root 2 meter per second square. 1. Now similarly, we draw for block B also. For block B, and we have MBG divided two components. This is 45, so this is 45, so we have MBG sine of 45, and we have MBG cos of 45, and this is normal NB, and we say it is moving down the inclined plane with the acceleration of AB. So we have a frictional FRB in upward direction. So we can write that our FRB will be equal to mu B into NB, and our NB is equal to mbg cos of 45. So we can write mu b mbg cos of 45. Now we can write the equation for motion. We get mbg sine of 45 minus frb is equal to mb and acceleration of b. We substitute the value of frb. So we get this as mbg sine of 45 minus mu b mbg cos of 45 is equal to mb multiplied by ab. And from here mb is cancelled out throughout. So we can say acceleration of b g is 10 sine 45 1 by root 2 minus mu b is 0.3. This is 10 and this is 1 by root 2. So we get our acceleration of b is equal to 3.5 root 2 meter per second square. Question number 2. And it is given that block B is root 2 meter ahead of block A. Okay. So in case we say let the distance traveled by, let distance traveled by block B before both come in a line is SB. Therefore, this is for block B, and therefore for block A, if it is SA, then SA will be equal to SB plus square root of 2. Okay, because SA is already behind SB by root 2. Okay. So in this case, if they are meeting at this point, then our block A is here and we have block B. So this distance for block, you can say B is SB, and this distance is given as root 2. So block A will be traveling a distance of SA, which will equal to SB plus root 2. And we can write now the equations. Okay. So we can say for block A, we get SA is equal to UAT plus half a t square. Initially both are at rest, so we can say that our UA is equal to UB is equal to 0. So from here we can say that our SA will be equal to half a t square. Let this be equation number 3. And for block B, we can write SB is equal to UBT plus half AB t square, and we can say that here SB is equal to half AB t square. This is equation number 4. And here at T, Now the thing is that SB distance by block B will be traveled in time t, and the same the block A will be traveling the distance SA in also time t. Now we can use that, you can say, but SA is equal to SB plus root 2. So using equation 1, 2, 3 and 4. Using equation 1, 2, 3 and 4, we get half a t square is equal to half AB t square and plus root 2. So from here we can take half as common and as well as t square. We get acceleration of A minus acceleration of B. A is equal to square root of 2. So this comes half t square. Acceleration of A is 4 root 2 and B is 3.5 root 2. A is equal to root 2. So root 2 cancels out and we get this as half t square, and this will be equal to 4 minus 3.5, that is 1 upon 0.5. So we can say t square A is equal to 2 divided by 0.5, or we can get t square A is equal to 4. So therefore t will be equal to 2 seconds. So you can say this is the time after which block A and B will come in same line, And next is we are going to find out distance. That is, we can say our SA is our half AA t square. So we get half, acceleration of A is 4 root 2 and t square is 4. So we get SA will be equal to A to root 2. Okay. And for B, SB is equal to half AB t square. So this is half, and we get AB is our AB was 3.5 root 2 multiplied by 4. So this goes by 2 and this comes out 7 root 2. So these are the respective distances traveled by the block A as well as block B. This will be meter as well as meter, and this is seconds. Yeah, here. So this completes the question. Thank you.